In this video, we're going to look at the second half of lesson 3.2, which is going to cover some rules and formulas that we can use involving the variation of a data set. Now we're going to start here just by going over a quick intro of some of the ideas we're going to cover before we move over to Excel and actually do some calculations. So, the first place we have to start. What does our data look like? When it comes to the shape of our data set, there are really two things that matter, or two answers we might get as far as what is the shape. The first is, well, our data set is normally distributed. That means that the histogram makes a nice bell-shaped curve like this. It's roughly symmetrical. There's not a bunch more on the left or a bunch more on the right. It's roughly a symmetrical shape. The other option is, well, it's not normal, and that might mean it's skewed, which means there's more on one side than the other, or it might mean it's something like bimodal, where that means there are two bumps, right? The big thing we have to decide is it normal or not? The reason this is important is that certain rules and formulas only work if our data set is normally distributed. The first one is the empirical rule. The empirical rule only works for normal distributions. We cannot use this rule if our distribution is not normal. Now, what does the empirical rule tell us? I think this is best explained by actually looking at a graph and then looking at some quick numbers on the side. So the empirical rule tells us that, hey, if I know the mean of my data set and I know the standard deviation of my data set, then I know how many of my data points will fall within certain ranges of values. So specifically, I know that 68% of my data will fall within the mean plus 1 standard deviation and the mean minus 1 standard deviation. That'll be 68% of my data that falls between those two numbers. And similarly, 95% will fall between plus 2 standard deviations and minus 2 standard deviations, and so on. We've got 3 standard deviations plus or minus. 99.7% of data will fall in that range. So what does it actually end up looking like? Let's just look at an example problem here with some easy numbers and no context to worry about, where our data set has a mean of 10 and a standard deviation, S, of 2. So what this tells me here is that if I look at plus or minus 1 standard deviation, that means I do 10 plus 2 to get 12, and I do 10 minus 2 to get 8. Between 8 and 12, 68% of my data will fall in that range, because that is the plus 1 standard deviation and minus 1 standard deviation. If I do plus 2 standard deviations, so that's 10 plus 2 plus 2, so that's 14, and 10 minus 2 minus 2, so that's 6. In that range of values, so it's plus or minus 2 standard deviations, in that range of values, I'm going to have 95% of my data. And we do the same thing for 3 standard deviations. That's going to be between 4 and 16. That's going to be 99.7% of my data will fall between the values of 4 and 16. So pretty much all of my data will fall in that range of values. The second rule, so we're going to use Excel to do this other part later. The second rule we're going to look at is called Chebyshev's theorem. Fancy name, but the rule is very similar. What it tells us is how much of a data set will fall within certain ranges of values. The difference here is it works for all shapes of data, so it does not have to be normally distributed, which, remember, the empirical rule had to be normally distributed. So Chebyshev's rule specifically tells us, hey, again, if I know my mean and I go plus 2 standard deviations away and minus 2 standard deviations away find those numbers, at least 75% of my data points are going to fall within that range of values. And then if I go plus or minus 3 standard deviations, well, now 88.89% of my data or more is going to fall within those values. And we could do a similar calculation to the empirical rule one we did above, but I will save that for the Excel part of things. So this was just a quick intro. We are going to now go over to Excel, and we're going to put these rules into our reusable spreadsheet and actually one or two other formulas that go along with them.